Hello, welcome to another video with me, Mr. Robertson, and today I'm doing a bit of chemistry, and I'm talking about if something is a chemical or a physical change. Chemical or physical changes. There's a bit of light in the way there. I might move this a bit up maybe. That's a little bit better. Chemical or physical changes. Now, there's a difference here between what happens for the two different ways things can change. Chemical changes, we make something new. So it could be, for example, if I have bread and I get it really hot, I can make toast. Toast is definitely different than bread. It's not the same thing. So I've made something new. I've had a chemical reaction. Bread and toast is a classic one, of course. I could mix chemicals in the lab together, make explosions, make gases and bubbles come up and all sorts. Those kind of things are chemical reactions. They make something new, and therefore as well, we can tell something. They may give out some energy, so they may make a sound or have different colours. There is some kind of energy or colours, or you'll see the change. You'll see the change happen, and that change for the chemical is irreversible. Irreversible meaning that I can't get it back. I can't get toast back to being just bread. It will always just be toast. As soon as I cook something, I can't get it back to being what it was before. Anything like that is going to be almost always a chemical reaction. Now, if I go to instead the physical, I don't really make something new. What I'm making is something that is just different. It could be, for example, having water and putting it in the freezer. I make ice. It's different, but there's still the same water molecules in there. It's not changed. They're just fast together now. It's not different. It's not really something new. Or I could have some salt in some water. I make salt water. But the salt and the water haven't changed. They're still just there, just salts floating around and dissolved in the water. It's not changed any of the things at all. So it's a physical change, we say. It's not really something new. It could just be changing its state from a solid to a liquid, getting hotter or colder. Or dissolving. They are very common changes, physical changes. They're not new reactions. I could take this rubber here and I could cut it into tiny, tiny pieces. I've changed it, but I've not made anything new. I've not made a new reaction. These things, usually these physical changes, are reversible. I can get them back. I can find my original product again. My water gets cold, it turns to ice. My ice gets warm, it turns to the very same water. It's a physical change, not a chemical reaction. There's a difference there. Now, that brings me on to the second thing to talk about, which is then to go through how we separate these things. I talked about having salt and water together. So how can I get them separate again? Now there's many different ways we can use to separate things. One, and the one I would use for salt and water, would be the process of evaporation. And of course, you know that from the water cycle, because water will evaporate up from the liquid and to be a gas. That happens all the time. Salt will not evaporate. So if I had salt and water, here's some salt in that water, my salt's going around, and then over a long time, so this water will turn to a gas, it will evaporate, and then all I'll be left with is that salt at the bottom. I have separated them. So my water is now out, my salt is there, and if I got maybe the air above here a bit colder, I can get some water next to it as well. That's evaporation. There are even more simple and faster ways though. If something is so big it doesn't even dissolve, I could use a filter and do filtration. Now if I have a filter, then what I'm able to do is I can set up maybe a funnel, something like this here, and then put in the filter paper. I know we've seen this in the lab year 6, and then have, as I pour in something, so I could put in sand and water, because sand doesn't mix in, it doesn't blend in with the water, it does not make a solution. So the sand cannot fit through the holes in the paper. So at the bottom here, all I get is the water, and the sand is stuck in there. And that's filtration. There's one more method I can use for separating things, and that instead is distillation. And distillation is when I need to separate two different liquids that are mixed together. And this can be quite hard, because the liquids, I can't block them and I can't just let it all evaporate, because then they both evaporate together. I do evaporation, but I need to control it, because different liquids can have different boiling points. For example, water will boil at 100 degrees Celsius. That's when water boils. But maybe it could be mixed with ethanol, an alcohol product. And ethanol will boil around 70 degrees Celsius. So what I can do here, right, if I get it in between these two, the ethanol will be a gas and the water will still be a liquid. So I need to get that temperature in between. It's the same as evaporation, but I need to make it a little bit more controlled. That's the trick to distillation. And that is the end of this video. Chemical and physical changes, differences between the two, and some different ways of separating materials. Bye from Mr. Robertson. Take care.